Let's start new topic, isotopes, and it is very important, isotopes. Now what are isotopes? It has been found that the mass number of all the atom of a same element is not same. Mass number is not same of a same element. Do you know the atomic number is the identity of element? Atomic number 1, hydrogen. Atomic number 2 means helium. Atomic number that you can immediately name the element. There is always a very small percentage of atom of a same element which has different mass number. Always a very small percentage of atoms, very small percentage of atoms of a same element which has a different mass number, same element having the different mass number. How? For example, I explain karta pehla yahan jo liye. Hydrogen have 3 isotopes. Same element indicate atomic number but the different mass number. Definition, atoms of a same element having the same atomic number but different mass number. And mass number is different because of the different in neutron number. For example, hydrogen has 3 isotopes: protium, deuterium and tritium. Hydrogen 1 and 1, hydrogen 1 and 2, hydrogen 1 and 3. 1 indicate atomic number, that the same atomic number. And 1, 2 and 3 indicate superscript, indicate mass number. They have different mass number. Now this is the structure of protium. Proton 1, atomic number indicate proton number and electron number, 1 electron. Proton number 1 and 1 electron, atomic number. Proton number 1 and 1 electron. 1 proton and 1 electron, that is the atomic number. But mass number, what is mass number? Mass number proton number plus neutron number, that is mass number is 1. So in protium, neutron is 0. 1 plus 0 is 1. Mass number is 2, so neutron number is 2. Sorry, 1 and 1 is 2. And mass number is 3, so neutron number is 3. So respectively, same element, name of the element, type of the element decided by proton number. Proton number 1, that is definitely hydrogen. But the mass number is different, 1, 2 and 3. 1, 2 and 3. So these are known as isotopes of each other. Mass number 1 is protium, that is ordinary hydrogen. Most of the hydrogen is available is this type or this form. It's a normal hydrogen, ordinary hydrogen. Deuterium, 1 proton, 1 neutron, mass number is 2. Okay, so got it? What is isotopes? Isotopes of a same element having the same atomic number but different mass number are known as isotopes of each other. Since the chemical properties of element remain the same, because the chemical property depend on the number of electron, but the number of proton equal to number of electron. So all the 3 kind of hydrogen, protium, deuterium and tritium, electronic configuration is 1, outermost orbit only 1 electron. And chemical property depend on the electronic configuration. So chemical property of the isotopes remain same irrespective of the different mass number. Though they have a different mass number, still their chemical property is same. It is obvious that atom of a given elements have the same number of proton, है ना, it is obvious. Same element, so same number of proton and hence same number of electron, because proton number equal to electron number. But different in mass number is due to different in neutron number, due to excess or a less number of neutron than the normal atom of element. Yani different in mass number is because of the different in neutron number. Such atom of a same element have a different mass number, same element means same atomic number, same proton or same electron number, yani Z number same, that is known as the same element, but have a different mass number, are called isotopes of each other. Now the definition: isotopes of protium is 1 and 1, mass number is 1, atomic number is 1, so neutron number is 0. Deuterium, mass number 2, atomic number 1, so A minus Z is neutron number, so neutron number is 1, and neutron number is 3 minus 1 is 2, A minus Z, that is the number of neutron number. So this is the configuration of protium: 1 proton, 1 proton, 1 proton, 1 proton, 1 proton, 1 proton. Mass number 1, so 1 plus 0, 1 plus 1 is 2, 1 plus 2 is 3. The mass number 3, the neutron number 2, mass number 2, neutron number 1. Okay. Now second, the chlorine has 2 isotopes. Each and every element has isotopes. Now I can draw figurative, I can easily draw the figures of 2 types of chlorine atom, 2 isotopes of chlorine. Now subscript indicates 17. So atomic number, yani proton number 17. But the mass number is 35 and 37. Mass number is 35 and mass number is 37. So Z is 17 and A is 35. So number of neutron is 35 minus 17 is 18. So 18 is neutron number. And here the neutron number is 35 minus 17. Sorry, here kitla che? Different is 37 che. Here 37 mass number. So neutron number is 20. And number of proton equal to number of electron in its outermost orbit. So first orbit 2, 8 and 7. And still in this 17 protons, 17 electron, 2, 8, 7. So all these 2 isotopes, electronic configuration is same, 287, so that chemical property is same. Though they have a different mass number 35 and 37 and different neutron number, because chemical property depend on not the number of neutron but the number of electron and its electronic configuration. But proton number as well as electron number remain same. Electronic configuration remains same. Hence 2 isotopes of chlorine or any element's isotopes, their chemical property remains same. Right? The mass number, atomic number and geometrical representation of these isotopes are given below. અહીંયા આપેલું છે, અહીંયા બતાવ્યું મેં તમને 17 proton, 18 neutron, 17 proton, 20 neutron. અહીંયા બતાવ્યું 20 neutron. Okay. But the electronic configuration is 287 remain same in both. Now other types of only the hydrogen isotopes, chlorine isotopes, now carbon isotopes. Carbon 612 and 614. Yani 6 indicate number of proton as well as electron. So how can we write, how can we show that isotopes of C6H, C612, 614? Yani carbon have two isotopes, 612, C614. Okay, so proton number is 6, proton number 6. Electron number is 6, electron number is 6. First orbit 2, last orbit 4 electron. 2 and 4 electron. You have to draw the circle, whole circle. And mass number is 12. Mass number is 12. So neutron number is 6. Mass number is 12. So neutron number, 14. The neutron number is 8. Okay. They have different neutron number but same proton number, same electron configuration. So chemical property same. Same as different element have isotopes. Each and every element has its isotopes. Oxygen is mainly 816, but however it has two isotopes, 817, 818. And neutron number is 8, neutron number is 9, and neutron number is 10. Okay, and proton number is 8, proton number 8, and proton number 8. So mass number is 17, mass number is 18, mass number is 16. Same as potassium, isotopes, uranium 92 is very important. Uranium 92, 238, 92, 235 are the isotopes of uranium. Now state the property of isotopes. Isotopes ni property jo hai. Properties of isotopes. Whose atomic number? Same. The atomic number, that is the number of proton in all isotopes of an element is same. Thus, the chemical property of all isotopes are identical because proton number equal to electron number. So, electronic configuration is same. Electron distribution and has the number of valence electron. Electron distribution means electronic configuration. Hence, the outermost orbit, valence electron means outermost orbit, electrons are same. Of all the isotopes, same elements are similar. All isotopes have a same element, have same valency. Valency. અત્યાર સુધી આપણે valency નથી આવી. What is valency? Number of electron gain or loss is known as a valency. For example, sodium number 11. So electronic configuration is 281. Outermost orbit is known as valence electron. Okay. So if sodium want to complete its octet, it donate 1 electron because it is very hard to gain 7 electrons. So it donate. So number of electron donate is known as valency. So 1 electron donates, so valency is plus 1. So valence electron 1 and donate, hence valency is plus 1. Now what about chlorine? Chlorine number 17. Electronic configuration is 287. Outermost orbit, number of electron, it is known as a valence electron. Valence electron is 7. But to complete its octet, it is hard to donate 7 electron and easy to gain 1 electron. So gain 1 electron, the number of electron donate or gain is known as a valency. So its valency is minus 1. Because it gain is minus 1, loses plus 1. Got it? Valence electron 7, valency is minus 1. समझ में आयो? Now what is valency? Have same valency. Same valency matlab they have same electronic configuration, they have a same valence electron, so all have same valency. Yani number of electron gain or loss of all isotopes is same. They have physical properties. The physical properties such as density, melting point, boiling point, etc. of isotopes of the same element are different. What is same and what is different? Chemical properties same, valence electron same, valency is same. But what is different? Density, melting point, boiling point, mass number. Mass number is always different. ये तो question में जो है mass number different, density is different of isotopes of same element. Now fractional atomic mass. ને કોઈ વાર એવું હોય કે જેમ કે ક્લોરીન છે, ક્લોરીનનો માસ નંબર આપણે લઈએ છીએ માસ નંબર 35.5. How can it be possible? Because number of proton and number of neutron are the whole numbers. Then how can a mass number be a fraction? કેવી રીતે fraction number is a very important topic. Fractional atomic masses of element. The mass of proton or a neutron is accepted as 1 AMU. Mass of proton and neutron, never fraction as a whole number. 1 proton, 1 AMU, 1 neutron, 1 AMU. As the mass of an atom is the sum of mass of proton and neutron, mass number. What is mass number? Proton plus neutron. It is expected to atomic mass of an element should be whole number, no? Because proton is whole, neutron is whole, so its addition is whole number. But however, in many cases, the atomic mass is not close to the whole number. It is because no elements found to have same kinds of atom, because they have isotopes. Some fraction of atoms in a given elements have more or less number of neutron in the than the normal atom. Yani when you take chlorine from the atmosphere randomly, right? So in the mixture you can get the two types of the chlorine. Actually, do you know we inhale two types of oxygen? Oxygen છે mainly R type નો હોય છે 816, but other two types of oxygen are also we inhale. So we inhale the oxygen is not the same kind. They are a 2 to 3 kind, but the chemical property is same, but the mass number is 16, 17, 18. So when we take any element, same element, but due to presence of isotopes, they are not of the same kind. They are of a different kind. Okay. So when some fraction of atom, yani some part of atoms in a given elements yani mixture of elements, when you take oxygen, when you inhale oxygen, you are not inhaling same kind of oxygen. So when oxygen is given, some fraction of atom have a more or less number of neutron than the normal atom. When this is, for example, this is the mixture of oxygen, but mixture of oxygen, then some fraction of oxygen have a more or less the number of neutron as compared to the normal oxygen. This is normal oxygen mainly, while some atoms of the oxygen have a different number of neutron, maybe. So given rise to fractional atomic number. How fractional atomic number then? The following example will illustrate the point. એના માટે આપણે પહેલા example જોઈએ. Okay, for example, natural chlorine has 2 isotopes. જ્યારે પણ આપણે chlorine ને લઈએ ને 2 isotopes, chlorine 1735 and chlorine 1737 and 1735. Two types of chlorine are available in the ratio of 1:3. When you take randomly four atoms, then one kind of chlorine you get this kind, and 3 atom of chlorine you get this kind. Randomly લઈ લો 4 chlorine atom, તો તમને રેશિયો આ જોવા મળે. ઓકે, સો માસ નંબર ઓફ ક્લોરીન 37. તો આપણે શું લેવાનું? મીન નંબર લેવાનું. સો મીન માસ નંબર ઇઝ આ 1 છે, આવા 3 મળે. 37 + 35 + 35 + 35 by 4. Right? So 70, 140, 142 by 4. 142 by 4. That is 71 by 2. So 35.5. So mass number not 37, not 35. We generally take the mass number of chlorine is 35.5 on an average, because not mass number never be in a fraction. Mass number ક્યારે fraction માં ના હોય. But what kind of the mass number then I take when I calculate? Calculation માટે 37 લેવાનું કે 35 લેવાનું every time. So we take mass number as average of type of chlorine mass available. Yani always chlorine available are of a 2 kind of isotopes, 1737 and 1735, and the ratio of 1:3. So average mass number is 35.5. Okay. Now example, chlorine has 2 isotopes. Chlorine 1737 and 1735, and the ratio 1:3. So atomic mass of the natural chlorine. So what mass number I take when I do any sum, when I do any calculation, whether 37 or a 35, which number I would like to take? So we will calculate the mass number. Yani 1737 is only 1 atom, yani 17 into 1, and this kind of a 3 atom, 35 into 3, 105. So atom of a 4 natural chlorine is 17, and 105 divided by 4 is 35.5 AMU. Right? Thus the example clearly proves that the atomic mass of the natural chlorine is a fractional number. તો આપણે જે નેચરલ ક્લોરીન છે એનો એટોમિક માસ નંબર આપણે ફ્રેક્શનલ નંબર રહીએ છીએ. એકચ્યુઅલી પ્રોટોન નંબર એન્ડ ન્યુટ્રોન નંબર નેવર બી ઇન અ ફ્રેક્શન, never be in half. Still the fraction number is because of is average of the mass number rather than the whole number. Similarly, atomic mass of other element is fraction number. Sample number 1. The table given below shows the number of proton and number of neutron in the nuclei of element P and Q. Calculate the mass number of P and Q. What is the relation between P and Q, and which element do they represent? Chalo, this is P, proton number and neutron number. Chalo, અહીંયા P હું draw કરું છું. P, proton number 1, neutron number 1, so mass number 2. Second Q, this is P, is Q, proton number 1, neutron number 2, so mass number is 3. Having the same proton number, so both are of a same element, hydrogen 1 and hydrogen 1, because atomic number 1, that is hydrogen, and mass number 2 and mass number 3. So before few minutes we discussed about the 3 different types of hydrogen isotopes. Protium is a deuterium and tritium. Right? So P and Q are the isotopes because they have the same atomic number but the different mass number 2 and 3 respectively. So P and Q represents the isotopes of hydrogen and their name are deuterium and tritium. Now problem number 2 are the symbols. WXYZ. Out of Proton number 91, proton number 92, proton number 92. So X and Z, we can say their atomic number are same. So they are of the same element. Okay. And 91 and 93, there is no question about the isotopes of each other. So we will discuss only X and Z. Isotopes are the atom of the same element having the same atomic number but different mass number. So nuclei of X 92-235 and Z 92-238 having the same atomic number, that is 92. But the different atomic masses because the different number of neutron and mass number is 235 and 238, hence they are isotopes of each other. They are the isotopes of each other, right? Okay. Now chemical bonding is very important as per the 10th standard, because in the 10th 2 chapters will be you have to study in 10th standard, chemical bonding and different types of compound. Ema avse chemical bonding. So this is the base of your 10th. Now chemical bonding. Chemical bonding. Introduction. When the atom of a same element or those of a different element, same element or a different element, what does this same element and different element suggest? If the same element, proton number same, but the different element, proton number different. Whether the same element combine or a different element combine to form a molecule. For example, oxygen and oxygen combine to form O2, oxygen O2. Or sodium and chlorine, the same element combine to form a molecule or a different element combine to form molecule. NaCl. To different element combine or to same element combine to form molecule. So one molecule of oxygen, one molecule of sodium chloride. But when two atoms combine, because a force of attraction developed between the participating atoms, why they come close with each other? Because some kind of force, that this line suggests that some kind of the force excitate between two atoms, hence they come close with each other and form a molecule which holds together. The force of attraction between two similar or a dissimilar atom. Force of attraction between similar or two dissimilar atom in a molecule is called as a chemical bond. This is known as a chemical bond between oxygen and oxygen. This is known as a chemical bond between sodium and chlorine. So what kind of this bond in oxygen and sodium and chlorine? It has been noticed that formation of a chemical bond result in a decrease in energy of the participating atom. Before participation, they are very energetic, but after bonding, their energy decreases. Because you can see that before sodium, electronic configuration is 1. Because its atomic number is 11. Outermost orbit 1 electron, so it is so energetic, and the sodium try to find other partner to give its 1 electron. Outermost orbit 1 electron. And chlorine number 17, its electronic configuration is 287. Okay, 287. Outermost orbit 7 electron. So chlorine is very active and try to complete 8 electron at the outermost orbit and try to gain 1 electron and try to find very active. So high energy before bond. But when sodium give 1 electron to chlorine and accept 1 electron, chlorine accept 1 electron. So electronic configuration of sodium become 281. 2 and 8, and chlorine electronic configuration become 2, 8 and 8. That is active, octet complete. So, Vishanditi બેસી જાય. There is no need to gain or lose electrons. So, they are very peaceful, very calm, low energy. So, when they transfer electron, so bond is between Na plus and Cl minus, because it donate one electron, become Na plus, gain one electron, Cl minus, and positive ion and negative ion, that a bond is formed between less energetic ions. Okay, when the bond form result in a decrease in energy of the participating atom and hence result in a molecule or more stable. But now when they form molecule, they don't have any energy. એ ક્યાંય નહીં જાય, શાંતિથી નીચે બેસી જાય and એક molecule બનાવી દે. So it's more stable. Then the participating atom, participating when they are atom, their outermost orbit is not fully filled with electron. So they are very energetic and find someone to give or to donate or to gain electron. So atom, high energetic, molecule, more stable and less energetic. Atom. For example, the molecule of Cl2 is more stable than the 2 atom of chlorine. 2 atom of chlorine, એના કરતાં જે Cl2 બની જાય ને એમાંથી molecule of chlorine, when the same atom form molecule, different atom form molecule NaCl. Okay. Then the 2 atoms of chlorine. Because the molecules of chlorine has less energy than individual atom of chlorine. Why do the atom enter into the chemical bond? Chemical bond ma jai when they form molecule that energy decreases? Because chemical inertness of a noble gas. હવે આપણે એના પહેલા જોઈએ. Before answering the question posed above paragraph, let us check the electronic configuration of the number of valence electron of a noble gases which is chemically inert. From the inertness, we mean that the noble gas do not react chemically either with one another or the other element. એકબીજા સાથે બી ના હોય, જેમ કે helium, neon, argon, krypton, xenon, radon. Helium, neon, argon, krypton, xenon, radon. Its symbol number 2, 10, 18, 36, 54 and 86. यानी first orbit 2 electron, neon 10, 2, 8, 18, 2, 8, 8, 36, 2, 8, 18, 8, 54, 2, 8, 18, 18, 8, 86. હવે ચલો તમને 86 શીખવાડો. ચલો first orbit 2, 8, થર્ડ ઓર્બિટ 18. હા, અમારી પાસે તો બહુ બધા ઇલેક્ટ્રોન્સ છે, એટલે 18 માંથી કેટલા ગયા? 18 માંથી 28 ગયા. 86 માંથી 8, 18 to 20, 28 ગયા. તો કેટલા બચે? 10 minus 8 is 2 plus 6 is 8, यानी 58 बचे. तो 58 છે તો થર્ડ ઓર્બિટ તો 32 ભરાય, કારણ કે મારી પાસે 58 છે તો 32 માઇનસ કરો. 8 minus 2 is 6, 5 minus 3 is 2. Still I have 18 electron, તો અહીંયા 18 ભરો, તો minus 18 કરો. minus 18 કરીએ તો 8 બચે ને, તો લાસ્ટ ઓર્બિટ 8 ઇલેક્ટ્રોન થયું. 2, 8, 18, 2, 8, 18, 32, 18, 32, 18 and 8. Okay, this is the electronic configuration of a noble gases. Now you look carefully at the number of valence electron of a noble gases. Number of electron outermost orbit. First orbit તો 2 થી જ ભરાય ને 2 complete ભરાયેલી છે. The duplet structure and other elements have an octet structure. Then હવે હું એમ કહું કે આપણે આપણા નેબર સાથે રિલેશન ક્યારે બને, બોન્ડ ક્યારે બને? જ્યારે મારા ઘરે શુગર નથી તો હું એને ઘરે લેવા જાઉં, अथवा एना घरे नहीं तो मारा घरे लेवा आवे, राइट। का तो हूँ ए मने आपे अथवा हूँ एने आपू तो अमारा बने वच्चे रिलेशन थाय ने। पण मारा घरे एटली शुगर छे, वधारे बी नथी ओછી बी नथी, हूँ एने आपीश बी एनी पासेथी लईश बी नहीं, तो अमारा वच्चे कोई रिलेशन ना थाय, ओके, कोई बॉन्ड नहीं बने। So same, the elements whose outermost orbit is completely fully filled with electronic configuration, so they do not give electron to other elements, as well as they cannot accept electron from the other elements, so they are in the less state of energy, they don't have energy, and there is no need to gain or to donate electron, so it's remain alone, કોઈને પાસે કોઈની સાથે રિલેશન ના બનાવે, બોન્ડ ના બનાવે. If you look carefully at the number of valence electron of a noble gases, then the following conclusions can be drawn. Helium is the only noble gas which has 2 and only 2 electron in its valence shell, and such electronic configuration is known as a duplet structure. From the duplet structure, we mean that કોને કહેવાય duplet structure? The element which has only one orbit and one orbit માં 2 electron હોય. The element or ion should have 2 electrons in its valence shell. The number of electrons in atom or in ion, the total number of electrons in the atom or ion should only 2. For example, helium has 2 electrons in its valence shell, and the total number of electrons in it are also 2 and has a duplet structure. 2 electrons and valence shell ma pan 2 electrons. However, an atom has magnesium. This electronic configuration magnesium 12, electronic configuration 282, outermost orbit 2 electron, it's not duplet because total number of electron is 12, not 2. એની પાસે total number of electron भी 2 હોવા જોઈએ અને first orbit માં भी 2 હોવા જોઈએ. No matter it has 2 electron its valence shell. All other noble gases have 8 electron its valence shell. Such electronic configuration as valence shell is known as an octet structure. Yani except helium, other noble gas has 8 electron in its outermost shell. Since the noble gas do not enter in any chemical reaction, because they cannot enter in any chemical reactions because there is no need to gain or donate. It can be safely guessed that any elements or ion having 2 electrons or a duplet structure or 8 electron octet structure in an outermost shell will not tend to be chemically inactive. They are not active. Okay. So above observation was made by Cossel and Lewis independently in 1960 and further stated the duplet or octet configuration of electrons is the most stable, and any atoms or ion having the configuration will be minimum state of energy, yani they are very stable, minimum state of energy, they cannot donate, they cannot accept electron, and it is known as an octet rule. Okay, चलो ये रखिए.